Perfect.
Okay, so dear colleagues, we're happy to introduce you our paper Razmecheno, named entity recognition from digital archive of Diaries Prozhito. Please, the next slide, Kate. And first of all, we should give a definition of Prozhito. So what is it exactly? It is a digital corpus of personal diaries in Russian, Ukrainian, Belarusian. These texts were written from 18th to 20th century by more than 6,000 authors. Please, the next slide. Okay, and how is our work organized? What was its pipeline? We did a long-standing work from data collection to the conduction of experiments and obtaining the results and sharing them with you. Firstly, we chose the most interesting for us time period in which personal diaries were written. After we selected the texts written in such hard times as perestroika, we understood that what is naturally not all sentences included named entities. That is why we decided to train a binary classifier, which to predict whether there is a named entity in the text or not. To do so, we manually collected data with markup and trained our binary classifiers. After it, we used a crowdsourcing platform, Toloka, for the whole annotation of sentences, which included named entities according to the predictions of our binary classifiers. After the data set for named entity recognition task was collected, we conducted experiments using off-the-shelf tools and transformer-based models. And now we're going to tell you more thoroughly how our data was annotated.
So one of the most parts of our work was to find the perfect set of tags that we could use in diaries annotation. And we divided all the tags to two groups. The first one is related to people, and here we have two tags: person, which is meant for names and surnames of different people who are mentioned in the diaries, and characteristics. This is the tag that we made up for our work because in diaries, people are usually referred with their social belongings or titles or professions and nationalities. And it might be important to see how people are characterized in these diaries. And you can see the example of the person tag on the left side of the slide and the example of their characteristics tag on the right side of the slide. The second group is about tags for places. The first one is location, which was meant for geographical and geopolitical places, countries, cities, states. The second one is organization for different companies and organizations and so on and so forth. The next one was for facilities. It is not that popular among work on named entity recognition to use this tag, but we thought it would be very important to for diaries as well. And that means everything that is built by people, such as school, airports, and all these places. And you can see the examples on the slide as well. As mentioned before, we used Yandex.Tolaka, which is a platform that allows to hire people to annotate text or to prepare any other types of data. And the initial idea of our project was to use annotators at Yandex.Tolaka and to give them text from our diaries and ask them to annotate for this 6 tags with one additional. And we realized that they would be problematic because first, annotators get tired very easily because of this, because there are lots of tags and it's maybe hard to see the difference. And also because most of the tags in diaries did not contain named entities.
As we said, there is one more problem. There are no named entities in many sentences. Therefore, we're wasting money, time, and effort of annotators. So we wanted to find a way to minimize the number of marked up sentences without entities. And we decided to do a preliminary selection of sentences with named entities. For this task, we use data divided into two groups based on tags and their relatedness. The first group is per char, that is tags that describe some persons. And the second pool is ortholog fag, something about locations, accusations, and etc. And so we formulated following plan. First of all, we classified sentences on Toloka into two groups, containing entities and not containing entities. After that, we learned two binary classifiers for each group to predict presence of entities in a sentence. And finally, we mark up sentences with the highest probability of the named entities occurrence. And after first experiments, we understood this plan is working. So it transformed into our algorithm. And it is worth saying a few words about binary classifier. Its architecture was pretty simple. We just used some basic language model, and after that linear layer with two outputs for but we experimented with a few language models as basic models. There were Roberta, Robert, Robertini, and XLM Roberta. And you can see this table with obtained results. You can see that Robert showed best results in terms of F1 score, but finally we chose Roberta as the base model due to the fact that in this task, the precision is more important than the recall, because we mark up only part of the corpus, and therefore we still miss some of the information. But at the same time, we want to have any entities in the selected sentences with a high probability.
Thank you, Timofey. Then we made our main crowdsourcing tasks on Yandex Toloka for annotation our data set with named entities markup. Due to the fact that our annotators do not have any linguistic background, we have to prepare detailed annotation guidelines containing meaning and the explanation of each tag using common vocabulary, supported with examples from Prozhito, accompanied by markup of named entities. In addition, some helpful advices were included. On the right of the slide, you can see the section for a location tag from our guidelines. The next slide, please. Here is an example of crowdsourcing task placed in Yandex Toloka annotation interface. The phrase is Ira brought socks as small presents for Sasha. Blue is for person. For example, Ira and Sasha. On the right, there are buttons for selection of named entities. As I said, blue is for person, green is for characteristics, gray is for miscellaneous, and the checkbox at the bottom is for cases when there are no named entities in the sentence. The next slide, please. As for dataset descriptive statistics, you can see the graph in the table showing the distribution of entity types and their mentions. Thus, person is the most frequent tag. A little less than half of all entities are of this type. Persons are often provided via a few tokens. Naturally, that's because they often include names and surnames. The rest of types does not represent the same variance between mentions and entities. Miscellaneous entities are only 1% of all entities, as you can see. And the next slide, please. Furthermore, we can draw some conclusions relevant for the humanities from our data. This table represents top 10 mentions for each entity type. As expected, popular mentions of entities actually represent concepts and personalities of the perestroika period. As we can see, there are main politic figures in the list. For example, Boris Yeltsin, Mikhail Gorbachev, Nikolai Ryzhkov, as well as all Soviet political authorities, for example, Central Committee, the Communist Party of the Soviet Union, Politburo. Some words that were new at that time, such as a president, since Gorbachev became the first president of USSR in 1990, or parliament. The parliament of USSR was founded in 1989, are among the most frequent words. The mixture of old Soviet terms and new words illustrates this period as a time of transition. Next slide. Thank you.
So, and now we're going to tell you how we conducted our experiments. And the next slide, we can see a table of, I'm sorry, the first one was about the off-the-shelf tools. Kate, please.
Yes, so we tested different types of models, off-the-shelf tools and fine-tuner models that will be, you'll hear about them later. And we evaluated 4 off-the-shelf tools for name entity recognition for Russian language on our dataset: Spaces, Tanza, Natasha, and DeepPavlov. The models recognize person better and worse quality on other tags. And we also compared their performance on our dataset with their performance on other datasets. And as we expected, the models show worse quality in our datasets due to the specific source and validator. Diaries usually have complex narrative structure and sometimes even a plot. And that might be a reason that named entities are not repetitive and might be pretty unique. So it's hard for the models that were trained on news data to recognize these named entities as they are. The closer look at our data supports this idea. As we can see on the confusion matrices, the main problem of this model is that they do not recognize named entities and give them tag O, or they might see named entities where they're not. Yes, and you can also see that the only tag that they do not confuse with others is a person.
So now we will tell you about how we conducted experiments with BERT-based models. The top 4 results were gained with the Rubertani, Rubert, Roberta, and XLM Roberta models, and the best metrics were obtained with the fine-tuned Rubert model, which was pre-trained on a large corpus of Russian. And we consider Rupert as the best model for our dataset and task, because it successfully predicted both major and minor classes. And in the next slide, you can see our conclusion. So to conclude, we will just tell you what we've done. We developed a standard of annotation. We collected a corpus for named entity recognition task. We created a pipeline to enlarge our corpus. We have understandable instructions for assessors. The process of markup was organized in the local interface, which is a crowdsourcing platform. So it is not obligatory to involve assessors with linguistic education and collect our data constantly if we would like so. We introduced a new tag for named entity recognition task, which could be useful for future research and works. We conducted experiments on different approaches and found the best architecture to detect named entity in private diaries on our dataset. So we thank you for your attention.
Thank you for the nice presentation. Just arrived on time. And we have time for a few questions.
What type of features have you used to classify the named entities? What kind of feature you use? Context features, any terms which appear around the named entities, or whatever. What kind of linguistic features you have used to classify the named entities?
I'm sorry,
Question?
I misunderstood the question, and maybe my colleagues too. I'm sorry.
Anybody can correct other one? Okay, as I understood the question is about what kind of feature did you use to do this classification of name entity recognition? Was that correct? Yeah.
So do you ask about how our classifier worked, or why we divided into two groups our tags?
Maybe what kind of feature do you put in the classifier to make the classification?
Yeah, I think I got the question. So when we used off-the-shelf models, we did not fine-tune them or change anything. So we just used them as they were, and they did not use any features. And when we used, when we fine-tuned models, we did not give them any features. We just gave them raw text and annotation. We used BERT for named entity recognition, RUBERT, and it was already trained for this task, and we just fine-tuned on our data to improve the quality. But it takes raw text without any other additional features. So we did not use feature-based approaches in our work. And thank you for your question.